Hey everyone, welcome back to my channel EduVibe. In today's lesson, we're doing the practice question of the last part of this unit, which we're doing the modern physics. We cover the lots of things in that. We do the photon theory, we do the extra things in there, photon momentum, quantum effect, and the photoelectric effect, gravity analysis. We do all this topic in last part, and today we do the practice of this, and then we do the diploma questions with this because we end that unit. So that's why we do that thing. So the first question we have over there, the question says that determine the energy of the photon, joules and in eV with a wavelength of the 505 nanometers. So we have to find the energy. So find the energy, we have a wavelength, so use the Planck's equation, which is E is equal to hc upon wavelength. So for h, we want in like joules per second, so we start with joules per second. So we take like this, minus 34 joules per second, 3.0010 raised to power 8 meter per second. And the wavelength is 505 into 10 raised to power minus 19 meter. So when you solve this, you get about 3.94 into 10 raised to power minus 19 joules. This is a rounded value. And to convert it this into EV, so 3.94 into 10 raised to power minus 19 joules, you have to divide this by 1.60 10 raised to power minus 19 joules. Joules cancel out, and when you solve this, you get about 2.46 EV. This is again the rounded value. So you get the energy in the joules, you get the energy in EV. That's how you can solve this. It's an easy kind of question from the Planck's equation. Let's move on to the next one. If 40.0 volt monochromatic light source creates a EMI with the frequency of 5.36 10 raised to power 12 Hz, determine the wavelength in micrometers and maximum number of photons emitted by the light source per second. So we have the frequency, we have the power, you have to find the wavelength for this. It's easy to find the wavelength from here. You know C is equal to frequency times wavelength. So for wavelength is equal to the C divided by frequency. So 3.0 10 raised to power 8 meter per second. Divide this by the frequency 5.36 into 10 raised to power 12 Hz. When you solve this, you get about your wavelength of about 5.597 into 10 raised to power minus 5 meters. But you want this in microminutes. To convert anything else in this, you have to divide this. Divide this by your micrometers meter. So this is a prefix, and you get this from your data sheet. This has a prefix of 10 raised to minus 6 meters. So when you solve this, you get your wavelength of about 56.0 micrometers. This is the rounded value. So this is the answer for that. For next one, I'll find the maximum number of protons. So we use some formulas in that. We use some formulas which are not on your formula sheet. We discuss this formula when we're doing the photon theory. So you have to watch that video for this. So for B, we have to find firstly, to find the energy, N is equal to ET upon E photon. Basically, is equal to ET is equal to N E photon. So this we convert this into this, but we don't have ET, we don't have E photon. For E photon, for the energy of photon, we easily find from here. We know this H is equal to E for photon is equal to the H times frequency. We have both of things. So for H we create 6.63 10 raised to power minus 34 because we want it in joules. And for frequency we have 5.3 into 10 raised to power 12 Hz. When you do this thing and you get about 3.554 into 10 raised to power minus 21 joules. This is your energy for the photon. And you get this. So put it over there. Now you want an ET. Do the one more formula which is called P is equal to delta E upon T. That delta E is also equal to the ET. So This is ET2. So for ET, you have to find for P times T. Power is given to you, which is 40.0 volt. And they are asking about the per second. Per second means your T is equal to the 1 second. So take it as 1.00. And when you solve this, your ET is equal to 40.0 joules. Put this in also in that thing. When you solve the joules, you cancel out. You get about 1.13 into 10 raised to power 22 photons. So that's how you can find the number of photons emitted. So that's process you have to find, and this is the formula. This one formula you have to know. This is the formula which is not on your formula sheet. This is a h times frequency is your Planck's constant, so you have to know. So that's all what you have to show for this, and this is a two-part question, and let's cover all the photon theory questions. Let's move to the next one. The question says the minimum photon energy to emit the electrons from a metal surface is 5.28 in 10 to the minus 19 joules. Determine the minimum frequency to emit the electrons from this matter. The maximum speed of the emitted electrons if the incident electromagnetic radiation, which is photon, has a frequency of 9.0 10 raised to the power 14 Hertz. So firstly, you have to find the frequency, but you have energy of photon in this. But this is not directly the photon's energy, because this is kind of the thing they mentioned. This is the minimum photon energy. So when they mention the word minimum photon energy to emit the electrons, which means that thing which is given to you is your W actually. And also, now we have to find the frequency. They mentioned that we have to find the minimum frequency. Again, if the word is minimum is mentioned, so this means you have to find your threshold frequency, which is that. And we have a formula for this, which is W is equal to H times threshold frequency. Threshold frequency now is equal to W upon H. So W is 5.28 into 10 raised to power minus 19 joules. Divide this by 6.63 into 10 raised to minus 34 joules per second. The W is in joules, so you have to take Planck's constant also in joules. So when you solve this, you get about your threshold frequency of 7.96 into 10 raised to power 14 Hertz. This is the non-rounded one. So this is your minimum frequency. They directly not mention anything about that. You have to find the threshold frequency, but you have to know if there is a minimum, so to find the threshold one. So that's the thing. For B part, you have to find the maximum speed of the emitted electron. So for speed, you have one formula over there. So you know EK max is equal to half mv square max. This you know. You have to find the maximum frequency, which is 2 times kinetic energy upon mass, which is the whole root. You know the mass of the electron, but you don't know the kinetic energy. To find the kinetic energy, you have another formula we discussed when we do that topic called the photoelectric effect, which is photon's energy is equal to the EK max plus W. We do that thing. So EK max is equal to the photon's energy minus W. So to find this, photon's energy is H upon H times F minus W. W we have given. We have a frequency given to us. Now it's the frequency is called the F. So 6.63 into 10 raised to the minus 34 joules per second. Frequency is 9.00 10 raised to the power 14 Hertz. Minus this by 5.28 into 10 raised to the power minus 19 joules, which is your W. So that's all thing we have. So when you calculate this, subtract this, you get EK max of about 6.87 into 10 raised to the power minus 20 joules. This thing you have to put in now over there. So 6.87 into 10 raised to the power minus 20 joules upon your mass of electron 9.11 10 raised to the power 31 kg, root of this. When you find this, you get about 3.88 into 10 raised to power 5 meter per second. So again, this whole thing we properly discuss in the lessons when we're doing. That formulas which are you don't know, these are formulas are not in your formula sheet. These are the formulas which I discussed with you, which you have to be memorized in that topic, because these are the important things. And there's steps we have to follow in this, because there are lots of steps going on, lots of big calculations going on. So that's all thing I have to do. So calculate with your calculator with the correct numbers, that digits put on your calculator to get the answers. Where is the root? Where is the negative? Where is the positive? Where is the division? So all the things you have to be mentioned in this. That's the important topic. Next question. The question says, when electromagnetic radiation with a wavelength of 308 nanometers shown on a mantle, the minimum voltage required to stop the photocurrent is 0.707 volt. Determine the minimum frequency of the EMR to emit the electrons from the metal. So again they mention the word minimum electron, which means you have to find the threshold frequency at the end. For threshold frequency, you have a formula which is W times H times threshold frequency, which we discussed in that previous question. For threshold frequency, W upon H, you don't know the W, but you know the H. So for the H and W, I will discuss later on, but we first focus on the how can we find the W. So main focus is how to find the W. So for W, we have this. We know this formula again from the previous question. So for W now, photon times the kinetic energy. So for the W is equal to hc upon wavelength times the kinetic energy. Is the kinetic energy given to us? Yes, kinetic energy is given to us. So this is the kinetic energy. How this be the kinetic energy? I mentioned you this is kind of the stopping potential. So stopping potential is acts like a kinetic energy too. If when we discuss this topic, the photocurrent topic, we do one example where you have to find the kinetic energy. We get a kinetic energy something about 0.675. I'm not sure about this, but this is thing, and we get their EV. To get this stopping potential, we convert this into like this, and this whole thing is now your stopping potential. When we like left the E, and this is called the charge, when we left this, we get this in stopping potential. But if we want this in again EK mass, so we get the reverse of this. So this is the thing we do. So this 0.707 volt is 0.70 EV. We take it as a EK max. So now put the things in. So for this, always we use for the stopping potential graphs, we use the EV dot second H, which is the Planck's constant. So we get this minus 15 EV dot second 3.0 10 raised to power 8 meter per second divided by the wavelength 308 into 10 raised to power minus 19 meter minus this by 0.70 EV now. So when you solve this, you get 3.325 EV. You get the W in EV. So your W is in EV. You take H also in EV, which is your Planck's constant, EV dot second. When you solve this, when you divide this, you get about your threshold frequency of 8.03 into 10 raised to power 14 Hertz. So this is the thing we have to find. And why this question over there? We use the same formulas in this. But the main thing you have to notice was about the stopping potential. That how can we EK mass is connected to stopping potential, how the stopping potential is connected to the EK mass. That the conversion you have to know. This conversion is very important. We use that conversion in questions. Like in that question. This is a good question. So the things are repeating. The things are all the like modern physics we do, like last part. All the same formulas we use always. We do all the same formulas. Let's move on to the next question. We have the question says the wavelength of an incident S-ray photon is given to us, which is 5.150 10 minus 11 meters, and the wavelength of the scattered S-ray photon is 5.2200 10 minus 11 meters. Determine the scattering angle of the S-ray. So this is from the quantum effect, where we use the scattered and the S-ray, which is incident and the S-ray thing. So we have to mention that we have to find the Scranton angle. So for this, we have the formula given to us. So find the angle one. So delta H is equal to H upon MC 1 minus cos theta. We have to find the cos theta, so we have to isolate the cos theta from here. So MC delta H, a delta wavelength upon H is equal to 1 minus cos theta. The theta, now the 1 goes over there, we get with cos -1 is a reverse, so 1 minus MC delta wavelength upon H. Made the things up. So we have this is kind of the electron we do. So in this we do the electron thing always. So we take the mass of the electron in this. So 1 minus 9.11 10 raised to minus 31 kg, 3.00 raised to 8 meter per second, delta wavelength not given. We have to find this. So how can we find this? We have a incident wavelength and we have a scattered wavelength. So we know delta wavelength is also scattered minus initial, scattered minus incident, or you can say. So put the things in 5.200 into 10 raised to minus 11 meters minus 5.1500 into 10 raised to power 11 meters. So when you solve this, you get 7 into 10 raised to power minus 13, or you can take 7.00. Put the things in it and divide this by 6.63 into 10 raised to power minus 34 joules per second. So when you solve this, you get your theta of about 44.647 something, but rounded one is 4.4. The rounded one is 44.6 degrees, and this is your starting angle of the S. That's how you can solve these questions. You want theta, you have everything else except the delta H, but you have the scattered wavelength and the incident wavelength, so you could do minus this and get the delta H, delta wavelength, and put it in over there and get the theta. So that's the main question for the quantum effects, and these are very important questions. These are our questions. So let's move on to the last question of today's lesson. So the question says, the photon has a magnitude of momentum 5.07 10 raised to minus 22 kg/meter per second. Determine the frequency of the proton and the energy of the photon in keV. So you have to find the frequency in first part. How you can find? So we know that this is from like we have a momentum. So this is from like a photon momentum. So we know that NE is equal to PC. We discussed that formula in the lesson, and this is in a formula sheet. So E is equal to photon momentum, which is this given to us, times 3.010 raised to power 8 meter per second. So when you calculate this, you get E of about 1.1521 into 10 raised to power minus 13 joules. You get your E. You also know from the Planck's equation that E is equal to H times frequency. So frequency is equal to energy upon Planck's constant. So E is 1.1521 10 raised to minus 13 joules divided by 6.63 into 10 raised to power minus 34 joules per second. When you calculate this, you get about 2.29 to 10 raised to power 20 hertz. And this is your frequency, which you have to find. And for B part, you will find the energy of the proton in keV. You already find the energy over there. You have to just convert it into keV. So how can we convert this? Let's let this. So E you have is equal to 1.1521 into 10 raised to power minus 13 joules. Firstly, convert this into EV, which you have to divide this by 1.06 10 raised to power minus 19 joules. Joules cancel, and you get now 950625 EV. Now you have to cut this EV and convert it into keV. So for this, again, divide this by now 1000 because K means kilo, which is 1000 EV. So now EV again cancel. When you solve this, you get 9502.6 keV, which is also 951 keV. So this is a short kind of thing to get the energy in very short amount, 951, because this is so long. This is so long. So this is like a small thing, like 951 keV. So that's all you have to find, and that's how you can find this thing. Do the practice of that type of questions, and you get like know their formulas which are not on your formula sheet. Memorize them. It's very important. So that's all for this lesson. So this is the practice of the last part, and we completed the unit 2, and this is the last part of this practice questions of that part. And now we're doing the diploma question in next lessons, which are again very important, and again we officially complete that unit. So let me see if you EduVibe, learn smarter, not harder. Please like, share, and subscribe to my channel. If you have any questions, let me in the comment section. See you in the next lesson. Till then, see you with EduVibe.